Today we're going to solve exponential and logarithmic equations. But before we get into our equations, let's look at some very basic properties that we've looked at in the past and solve some one or two step equations that you've seen before. So the first example here, 3 to the x is equal to 27. Now I know all of you know that's going to be 3 because 3 cubed is 27. But let's take it from a rules perspective. When we solve exponential equations, we like to find common bases. So even though we know right here x is going to be 3, let's find a common base between the two sides, which 27 written in terms of base 3 is 3 cubed. Then I can see here I've got the same bases, the same quantities on each side, which means my exponents have to be equal. X is equal to 3. And that's why 3 cubed is equal to 27. Now some of you might say, well, why does that matter? Well, let's look at another problem that's not quite as clear cut. Let's say I had 25x is equal to 125. This is a problem you can solve real simply as well. Finding a common base between both sides and then setting the exponents equal once you have those common bases. So the common base relating 25 and 125 is 5. So 25 can be written as 5 squared, and since that x is there, we still need to include the x in the exponent. And 125 can be written as 5 cubed. Since I've got the same bases, I can use my one-to-one property and say the exponents have to be equal. So 2x is equal to 3, which means x is equal to 3 halves. So that's really the power in creating the common bases on both sides that we'll be using further along in some of the problems we'll be working with. The second example here, we've got log of 15 minus log of x is equal to 0, which means x is going to be 15. The reason for that is that if I have a quantity log of 15 here and I have to end up with 0, that means I've got to subtract everything, which means this log quantity has to be 15 as well. The other way you could look at it is you could move the negative log of x to the other side. So you say log of 15 is equal to the log of x, which then you can see the one-to-one property states that x has to be 15. The third example here, e to the x is equal to 12. Let's convert that to logarithmic form. So e to the x is equal to 12. Converting to logarithmic form is going to be x is equal to the ln of 12. For those of you who don't see that really clearly, what I did was I said x is equal to log base e of 12. The base of my exponential expression is the same as the base of my log. The answer to my exponential equation is the answer to the log. And then the 12 is the last piece over there. And we know log base e is the same thing as ln. The third example is converting from logarithmic form to exponential form. So here, 10 cubed is equal to x, which means x is equal to 1,000.